Welcome to Group 5's presentation on search and representation. In this video, we'll cover structured and unstructured data, how search engines operate, and the most famous search engine of them all, Google.
When discussing information, search, and filtration, it is important to understand how data and information are categorized. There are two primary categorizations, structured data and unstructured data. First, let's take a look at structured data, or data organized for computers. Wikipedia defines structured data as data that is identifiable because it is organized in a database where specific information is stored based on a methodology. Structured data is easily searchable, as it is already organized and formatted into something easily understood by a computer. Every bit of data is stored in precise categories, which makes finding exact matches a breeze. In comparison, unstructured data is defined as any data that has no identifiable structure. Images, videos, documents, and text are all considered unstructured data within a dataset. Unstructured data isn't as easily searchable, as it is difficult to database. Since unstructured data is so varied, it is hard to put each individual item into their precise category. BrightPlanet.com presents a good example of the difference between structured and unstructured data. Take the inbox of a corporate resource manager. While emails might be organized by date, size, and file formats, the emails are still considered unstructured. To turn these into structured data, they would need to be organized by exact subject and word-for-word content, with each deviation requiring unique categorization. Because humans don't communicate in precise and preset formats, organizing these emails would be difficult. However, we can't simply ignore unstructured data, as it comprises a vast majority of digitally stored information. A study by the EMC Corporation found that in 2012, there existed roughly 643 exabytes of useful data. However, only 3% of this data has been processed and tagged, or structured. A common technique for finding information is called tagging. Unstructured data can be tagged with metadata, or data that can be used to describe the unstructured data. Tagging can be done manually, but doing so is inefficient. Software engineers program crawlers to identify and tag unstructured data with metadata, so that one can search through unstructured data by looking for specific tags. Let's take a look at the components that make search engines run.
A search engine can be broken down into three main parts: the crawler, the index, and the query. Searching begins with the crawler. Crawlers are programs that automatically seek out web pages, files, and data and tags them. These programs crawl through links that are connected to the billions of interconnected pages of the World Wide Web, matching relevant data with appropriate tags. They then submit these tags to the index, a structured database that can be easily searched by you, the user. But how does the index know what document best matches your query? When a user enters a query, the search engine does a number of adjustments to the search to help the index find what it needs. First off, it deletes stop words like the, of, if, is, and or. This reduces the number of tags the index has to search for. Secondly, the search engine identifies multi-word phrases like catchphrase and hot dog, or phrases that are composed of words that individually do not make sense, but when combined signify something unique. Also, search engines give more priority to pages that have search terms near each other and in the same order as a query. Priority also goes to trusted, well-reputed, and highly visited web pages. These priorities come together to form page ranking, or the calculated relevance of a web page. While there are many breakthroughs in the formation of better, faster search engines, the only engine that has made itself synonymous with the word search is Google.
Search, or information retrieval, is one of the key information functions provided by the internet in the modern age. Google, of course, is the most prevalent and widely used system for searching the World Wide Web. In 2012 alone, the annual number of Google searches were 1,873,910,000,000. So let's delve a little deeper into this topic. So how does Google's ranking and website evaluation process work? Google's secret is its well-known algorithm PageRank, which is not related to web pages in any way, but is instead named after co-founder Larry Page. PageRank is essentially the rank of a page based on its traffic, number of links, and the reputation of those links, as well as some other smaller factors. Google keeps its algorithm completely secret, and with good reason. If anyone outside the company knew the algorithm, he or she could easily take advantage of the system, which we will discuss a little bit later. Even though the general public does not have access to the code, we have a general framework of how Google's algorithm provides relevant searches for countless queries. Google starts with crawling the web, with the page rank of a website being the primary determinant of how early in the crawl said website is discovered. After crawling a large fraction of the web, the search engine now has to index the crawled pages. Indexing includes much of the tagging infrastructure, organizing documents by the words they contain. But instead of indexing documents in word order, Google indexes words in document order in order to deliver results more quickly. Now comes the search query. To fulfill the query, the terms searched are sent to the closest data center, which then sends them out to the machines that contain their indexed fraction of the web. These machines then return the 10 pages with the highest rank that are closely related to the search query. Because the search engine provides the user with the creme de la creme of what they're looking for, users rarely have to go past the first page of Google. The balance of relevance and reputation is something that Google has mastered, which is why it's the world's most popular search engine. Now that we know how Google works in the present day, let's take a look at the major improvements that have been made to the search engine since its bold 1997 launch made by Larry Page and Sergey Brin. Google's algorithm is being constantly tweaked and refined to return higher quality results. In 2001, the search algorithm was completely revamped to make ranking easier. Update FRAPS of 2003 allowed Google to update its index constantly instead of in big batches, making a 5-week process much faster. In 2005, Google introduced personalized search, in which users could choose to let the search engine mine their search behavior to provide individualized results. Lastly, they added real-time search in 2009 that displayed results from Twitter and other blogs as they were being published. Google's search algorithm is always a work in progress and continues to add new features and efficiencies to the system, which is why it is still the only company whose name is synonymous with the verb search.
So what exactly is search engine optimization, or SEO for short? It is basically the different techniques a webmaster can use to improve his or her position in a search ranking. Unlike smart ads, where the owner can pay to increase trafficking for his or her website to be placed at the top of a relevant search list, search engine optimization requires understanding of how PageRank works to organically bring the website to the top of a list. Different ways to go about doing this are by using white hat or black hat practices. Black hat SEO uses unethical techniques such as blog comment spamming and keyword stuffing to get higher search rankings, which usually leads to a banned site, while white hat SEO techniques are about improving the content and redesigning the website to be more relevant in searches. Some examples of white hat SEO include improved content, better keywords, and link building, which is the use of social media links to improve link popularity. So this concludes our presentation on search and representation. We hope you enjoyed it, and thanks for watching. Here's our references.